welcome to this class. Today, we are looking at the topic circular motion. Circular motion. What is circular motion? Circular motion is simply defined as a motion round a circle. A motion round a circle. And when we talk of a motion round a circle, the simplest form of circular motion is constant regular motion, or a motion with a constant speed. Now, when we talk of a motion with a constant speed, the motion with a constant speed has a speed, but the velocity is different. Let's look at it this way. This is a circular motion, or this is a circle. This is a complete circle. You have A, you have B, you have C. At A, the speed is constant, but the velocity at A is different from the velocity at B as a result of change in direction. The velocity in A is different from velocity in B as a result of change in direction. Not only that, the velocity in B also changed, is different from the velocity in C as a result of change in direction. So the change in direction brings about acceleration, because there is a change in direction. That means there is a change in velocity, and as a result of change in velocity, there is acceleration, and the acceleration is called centripetal acceleration. Centripetal acceleration. The acceleration is called centripetal acceleration. That is an acceleration round a circle. And as a result of this acceleration, there is a force pushing the object towards the center of the circle. There is a force that is pushing the object, or that is pulling the object towards the center of this circle. And that force is called centripetal force. That force is called centripetal force. Now, as a result of this centripetal force, there is another force equal but opposite in direction to centripetal force. Centripetal force pushes toward the center of the circle. There is another force equal in strength but opposite in direction to centripetal force. That force is called centrifugal. You call it centrifugal force. That force pulls the object outside. Centripetal force bring the object to the center, while an equal and opposite force is pushing the force and the object outward. Now, as a result of centripetal force and centrifugal force, that is why the object is able to maintain the distance outside. The centrifugal force is pushing it inward. The centrifugal force is pushing the object outward. Because the strength of the two forces are equal, then that particular object is able to remain it's able to remain at that circumference. So it is the concentration of centripetal force and centrifugal force that actually keep the object moving at that circumference. Now, as I said earlier, you have the radius here. You have the radius. This R, this R. This is called theta. This angle is angle theta. Remember, I did mention that you have a constant speed, but the velocity changes. because there is change in direction. You know, velocity is a vector quantity that has to do with magnitude and direction. And because it has to do with magnitude and direction, the direction of the body in A is different from the direction of the body in B. The direction of the body in B is also different from the direction of the body in C. Despite the fact that it is same constant speed. So as a result of the change in direction, that is why we have change in velocity. Now, what are some terms that we use in circular motion? The first one we are looking at is angular velocity. The first one we are looking at is angular velocity. Let's look at it this way. Angular velocity. The angular velocity means angular velocity. Angular velocity. This angular velocity is actually defined as the angle between the ratio and the angle between the two radius. Between the two radius of the circle. This is the circle, this is the center, this is a radius, this is another radius. So this R, this angle, this angle theta. This angle is what we refer to as angle theta. Then the velocity here is what we refer to as angular velocity. It's what we refer to as angular velocity. So, and we know that velocity is displacement over time, which means the angular velocity mu is equal to displacement is equal to displacement. Now, as I said, we are looking at angular velocity and angular displacement. The angular displacement is displacement over angular displacement over time is equal to theta over t, and the SI unit is radian per second. The SI unit is radian per second. Let's also consider one other term that we use in circular motion. In our next lecture, we will continue with velocity, tangential velocity. As we know, this is a circle. This is a complete circle. We have a complete circle. This is a complete circle. And in this complete circle, there is a target. This is A. This one is the tangential. The body moving here is a tangential velocity. Having look at that, the tangential velocity actually is given as S over tangential velocity is equal to S all over T. The tangential velocity is S all over T. And S over T is R over T. Remember that we are dealing with this. And this is the radius. The radius is R. So this one is give me R theta all over T. This will give me R theta all over T. And remember that our angular velocity is said to be theta over T. So this one is the same thing as R times theta all over T. That is what that one gives us. That gives us R times theta over T. And we are told that our angular velocity, which is mu is equal to theta over T, which means this one gives us R times mu. This one will give us R times mu. Therefore, tangential velocity V is equal to R mu. Is equal to R mu. Tangential velocity is equal to R mu. Now, having said that, let's look at an example. Let's consider an example to bring home what we have been saying since. Let's look at an example, a simple example to illustrate what we have been saying. The example says a mass, or let me put this in, an object is attached. An object is attached to the end, of an elastic string. Of an elastic string. And wide round twice. Calculate the angular velocity. Calculate the angular velocity. Let's look at the solution. We are told that angular velocity mu is equal to theta all over t. Write that twice. Calculate the angular velocity if the time is 2 seconds. Calculate the angular velocity if the time is 2 seconds. We are told that mu is equal to this, and theta is 360. Theta degree is 360 degrees. But the question says it wide round twice. So which means we will have 360 times 2. That is wide round twice. It will be 360 times 2 all over t, where t is what? Is 2 seconds. Where t is 2 seconds. So if t is 2 seconds, then what does that actually mean? That means we have 720. This will give me 720. This and this will give me 720 degrees. This is 720 degrees. You can decide to do it this way. You can decide to do it this way. But I'm doing it this way because I want to take it down to pi. You know, we said it's radians. And because it's radians, we have to use pi. So in that case, what I have is 4 pi. This one, a pi is what? A pi is 360. A pi is 180 degrees. If 1 pi is 180 degrees, 720 will be 4 pi. So this will give me 4 pi all over 2, because the time is 2. That will give me 4 pi all over 2, and if that is correct, this will give me 2 here 1, 2 here 2. That will give me 2 pi radians per second. That gives me 2 pi radians per second, and that is actually the answer. Remember, I told you that the SI unit of angular velocity is radians per second. That's how we have it as 2 pi per second. So in our next lecture, we are going to consider other aspects or other terms that we use in circular motion. Please look at this thing well and make a comment, subscribe, and help us to transfer to others. Thank you.